So we're going to start ins and outs. Make sure you're doing the warm-up. A lot of you keep skipping this, so do this warm-up for me. For this one, on number 1, you're not going to do what they're telling you on number 1. I'm actually going to show you a video for that, but you are going to answer what you notice about the sum of these angles, these 3 angles. So here you have a triangle. We have 3 angles to this triangle. We have A, B, and C. So we're going to cut them out just like it said on number 1. So I'm doing this with you on the video. So once you cut out these 3 angles, okay, so A, B, and C, I want you to figure out if you were to line them up like so. So if you were to just put all of these 3 angles kind of fitting together like a little puzzle, I want you to tell me what type of angle do these 3 angles form in a triangle, and most importantly, how many degrees would end up equaling for these 3 angles that you see here on this triangle when they're lined up together like so. So you're going to answer number 2 and tell me what do you notice about the sum of these 3 angles. So hopefully you were able to notice that those 3 angles, they're actually going to form a straight angle or a line, which we know is equal to 180 degrees. Hence why every triangle that exists is 180. So now we're going to consider this diagram here, and they're asking us to draw an auxiliary line. That's a line that you have to draw anytime you are trying to complete a proof. Even if it's not there, you're allowed to draw this type of line just to try and get to your final proof. So on this one, they're telling us to draw an auxiliary line parallel to AB through point C, and we're going to identify the 3 adjacent angles. Remember, adjacent means next to each other, so they want you to create a line that is parallel, okay? And then they want you to identify the 3 adjacent angles that are next to C. Okay, so from that point. So you're going to go ahead and identify them. And you can go ahead and give them names, okay? Hopefully you were able to notice that the 3 angles that are adjacent are these 3 here that are labeled. So angle 1, 2, and 3. You could have named this angle 1, 2, 3 or 1, 2, 3, or even if you would have put a point here and called it another angle, that's fine too. But I'm going to just stick to angles 1, 2, and 3 because it's going to be less things to write down. So now that brings us to number 2. They're asking you to write a plan to prove that the sum of the interior angles of a triangle is equal to 180 degrees. So remember, what you are trying to prove, that is the last thing that you should be saying in your proof. But on this one, it's not a table proof and it's not a flowchart proof. You actually have to write a paragraph. So a paragraph proof is what it is. It's a proof that is written in the form of a paragraph. Make sure that your conclusion, your closing statement, the very last sentence for your proof should be that the sum of the interior angles of a triangle is equal to 180 degrees. I'm going to go ahead and start you off on this proof. The very first sentence that you should have written down is that angles 1 and angles 2 and angle CBA are congruent. So I'm going to write this down. So this angle and this angle, they are congruent. And hopefully you're able to notice that these lines are parallel here. And this transversal is the one that we're focusing on. So clearly these 2 angles are alternate interior angles. So hence why I can say that because this angle, angle 2 is the same as this angle, okay, you're going to keep going and figure out. The reason this is important is because remember, we said this straight line will equal 180 degrees. We also said that if I were to cut off this angle, and this angle from a triangle and line it up, they will form a straight line. So you're trying to prove that these angles here are congruent to every single angle that you have in this triangle, to then prove that if this line equals 180 degrees and these angles are congruent to the angles inside this triangle, then the angles on the triangle have to equal 180 degrees as well. But you can't get there unless you're proving each angle is congruent to each. So keep going with your proof. Okay, I've already started you on this one. And just so you know, you should have 3 more sentences or statements before you can close this proof completely. So you're going to have 1 more sentence to tell me, another sentence, and then this last sentence is what you are going to prove. And then that's what you would write for your last one. So now let's look at number 2. They're asking you to consider this diagram, and we want to go ahead and use this to prove that the triangle sum theorem. So we want to explain the diagram and how this demonstrates the triangle sum theorem. So remember, here we have another triangle. We know this. We know that this angle, and this angle will add up to 180 degrees. However, you have to prove this knowing what you know based on this diagram that was given to you. I'm going to help you start off. So I know this triangle equals 180. I also know that these angles here, they form a straight angle, a straight line. Therefore, this also equals 180 degrees. Okay? So, keeping that in mind, I need you to explain to me how is it that this diagram also proves, just like the last one, also proves that this triangle has to equal 180 degrees if this angle here, all of these angles, also equal 180 degrees. I will also start you off on this one. You're just going to explain, so kind of like a paragraph, little proof explanation. So for this one, I'm telling you that the first thing is that angles A and E, so I'm going to label them. So angles A, this angle here, and this angle, these are congruent because of corresponding angles. So the reason for that is, if you can see, you have little arrows right here. That means that those are parallel lines. So we have parallel lines, and then you have this transversal. We have corresponding angles here. So far I've already proven that angles A and E are congruent because of corresponding angles. You're going to go ahead and keep going. You have two more statements, okay, to be able to fully explain how this triangle is equal to 180 degrees. I'm going to give you a hint. You will have to mention something about substitution at some point, okay? But if I were you, I would go ahead and state which other angles can you see are congruent, and then go from there. Okay, so on this one, they're asking us to go ahead and see if the relationship exists, or how we can use this diagram to see if the relationship exists if we have the exterior angle of a triangle equal to the sum of the measures of the two remote interior angles. Now, if you remember, I had you guys draw this picture last time on your notes. I gave you a triangle here, and then I told you that this angle here was the exterior angle, and then I said that this angle and this angle, these are what we call remote interior angles. Now, the reason that you cannot call this angle right here a remote interior angle is because this line is supplementary. It is also adjacent, which means next to the exterior angle. Notice how the remote interior angles, they are neither supplementary or adjacent to this exterior angle. Okay, so that's how it always works. So now they're asking us, how does that relationship, how is that expressed here on this diagram? So on number 2, you should have been able to prove to me that this angle here, angle A, was congruent to angle A. You were supposed to be able to prove to me that angle B was congruent to angle D. And obviously, angle C is congruent to itself because of reflexive property. Angle C is equal to angle C. So if I were to give all of these values, right? So if I said this angle is 30 degrees, and if I said, now obviously these are just made up. If I said that this was 61, whoops, wrong one. If I said this was 61, and then I said that this was 89 degrees. Okay, so here we have 180 degrees for this triangle. Then that obviously means that if D is 89 degrees, then so is B. And if E is 61 degrees, then so is A. Obviously, angle C is 30 because it's 30 already and it's angle C. So now for this one, what they're trying to prove to us is that your exterior angle is going to equal the sum of your remote interior angles. And if I add 89 plus 61, okay, we're going to end up with the same thing if I were to add up 89 plus 61. So this is referring to the exterior angle, and this is referring to the remote interior angle. Both of these will add up to the exact same thing. So that is how we can prove, based on this diagram, that your exterior angle will always equal the sum of the two remote interior angles. So make sure that you are explaining to me how you know that this would end up proving or showing that relationship between the two.